Hello, welcome in the seventh day of physics. In the previous video we learned acceleration of gravity. We saw two equations, a long equation and a short equation for destiny, or you can say distance. We learned that if you wanna find the distance, so the equation is d equal to v0 into t plus 1 upon 2 into a into t square. But if you got the average speed, you will get vavj equal to v0 plus vf upon 2. This is the equation for average speed. Vavj equal to v0 plus vf upon 2. So you can use this short equation, which is nothing but the d equal to vavj into t, d into v into t, d equal to v into t, to find the distance. And in the today's section we are going to learn velocity, a vector quality. Often speed does not tell us all we want to know about motion. Often speed does not tell us all we want to know about motion. If you are told that while you slept your sheepdog left you at a speed of 5 mph and that he traveled in a straight line, you would not have enough information to go looking for him. Again, if you were told that while you slept your sheepdog left you at a speed of 5 mph and that he traveled in a straight line, you would not have enough information to go looking for him. Your dog left you at a speed of 5 mph in the straight direction. You don't have enough information, so you would also need to know in which direction he went. And although the term speed tell us how fast something is moving, although the term speed, again, term speed tell us how fast something is moving. The term velocity specifies both speed and direction. That's a killer move. What is the difference between speed and velocity? Speed just tells us how fast an object is moving, but the term velocity specifies both speed and the direction. Identify the two descriptions below as speed or velocity. Identify the two description below as speed or velocity. So the first question is 20 ms, which is nothing but the speed because it is showing us 20 m per second. It means it is showing us obviously speed. So the second question is 20 ms northeast. So this is gotta be velocity because it is showing the speed and direction. Northeast, which is the direction, obviously. I don't know if you guys know or not. If you guys don't know, you are a stupidest as to I ever met. Okay, again, speed tells us how fast or how fast something is moving, or you can say obviously speed tells us the object speed, and velocity specify both speed and direction. Okay, how does velocity different from speed? This is the question. How does velocity differ from speed? Obviously speed tells us how fast something is moving, and velocity tells us how fast and in which direction object is moving. Okay, so now we are gonna look at the equation of average velocity. Again, average velocity means nothing but the speed plus direction. Okay, so the equation for average velocity is vavj equal to d upon t. But in the v and the d, you can see up arrow moving at the right side. Notice that velocity is defined in the same way as speed, except that in this case we added arrows over some of the symbols. The quantities with arrows are vectors. Again, the quantities with arrows are vectors. A vector is an quantity that has direction as well as magnitude, size. What is the magnitude means? Size. The vector is quantity that has direction as well as magnitude, size. This is the very important part. Let's first start with here. The speed is telling us that how fast something is moving, and velocity telling us is how fast something is moving and what is the direction of that object. So in here, as you can see the two arrows over the V and the D, the quantities with arrows are vectors. The quantities with arrows are vector. A vector is quantity that has direction as well as magnitude. The quantity that has direction, in which direction arrows as well as magnitude, size. The symbol D and up arrow moving to right side, called the object's displacement. Again, the symbol D with the arrow moving to right side, called the object displacement, is defined as the straight line distance from the object's starting position to its final position, include the direction from start to finish. Again, the symbol D and arrows moving to right side, called the object's displacement, is defined as the straight line distance from the object's starting position to its final position, including the direction from start to finish. Thus, an object displacement might be started as 4.2 meter east. Let's say an object displacement might be started as 4.2 m east. So, which quantities in the equation above are vectors? So in this equation, VAV is equal to D upon T. Arrow is in the V and the D. So which quantities in the equation above are vector? Again, what is the vector means? The quantities with arrows are vectors. Obviously, the quantities with arrows are vector, or you can say the variable with arrows, or in the equation, the variables with the arrows are vectors, but in this book you can see we called that quantities. So the question is, which quantities in the equation above are vectors? Obviously V and D, because those both variables, or you can say quantities, have arrows. Okay, so the second question is, which are not vectors? Which are not vectors? Obviously T is not vector because T has no arrow. Suck you T, you don't have arrows, you ass. Okay, so in this equation, V equal to D upon T, V average equal to D upon T, just V and D has error, so it means those are vector and T is not vector. Okay, so now let's move on. We cannot assign a special direction to time, so it is not a vector. All quantities that are not vectors are called scalars. Identify each of the following quantities as a vector or a scalar. Again, we cannot assign a special direction to time. We can assign a special direction to time, so it is not a vector. All quantities that are not vectors are called scalars. All of the entities that are not vectors are called scalars. We can't assign a special direction to time. We can't assign a special direction to time because we can't assign a special direction to time, which is something that can't happen. We can't assign any special direction to time, so it is not a vector. All quantities that are not vectors are called scalars because time is a constant moving thing. You can't assign any direction to time, and that's why it is not a vector, and all of the quantities that are not vectors are called obviously scalars. So what is the scalars? No, tell me answer. Is velocity is vector or scalar? Again, we can't assign a special direction to time, so it is not a vector. All quantities that are not vectors are called scalars. So tell me, velocity is a scalar or vector? So obviously we can assign the direction because velocity is for speed and the direction. So we can assign the direction to obviously find the direction. So obviously velocity is vector because as you can see the quantities with arrows are vectors. The quantity with arrows are vectors. So yes, we can assign the arrows for, as you can see this equation has arrows. V upon arrows equal to D upon arrows and up upon 2. V arrow equal to D arrow upon 2. So as you can see V and D got the arrows, so this is obviously vector. This is the equation for average velocity, and obviously velocity is the vector. Now tell me, speed is vector or scalar? So we can't assign any errors in speed, and at the first starting the lecture, we learned that speed does not tell us all we want to know about motion. Speed does not tell us the direction. So that's why, obviously, this is scalars. Speed is scalars. Okay, time is scalars because we can't assign a special direction to a time, so it is not a vector. Okay, so the last one is displacement. Okay, so this is kind of weird. Okay, tell me, is displacement is a vector or a scalar? So we saw above that the symbol d upon arrow called the object's displacement is defined as the straight line distance from the object's starting position to its final position, including the direction from start to finish. The symbol d with the arrows called the object's displacement. Again, the symbol d with the arrows called the object's displacement. So tell me, does displacement have any direction, have any arrows in this? Yes, of course, yes. Displacement has a direction, so obviously it is gonna called vector. Again, we can't assign a special direction to time because time is only moving forward. Have you ever seen time moving backward? So there is only one direction we can't assign, which is forward. So we can't assign a special direction to time. It is not reversible, or time can't move backward, or you can't do anything with time. Time is just floating forward. Okay, so now let's move on. As you might have guessed, acceleration is also a vector. Acceleration is also a vector because we can assign the direction to acceleration, because acceleration is nothing but the changes in speed. Since we must take into account its direction, we have already seen in motion diagram that an object will speed up or slow down depending on the direction of the acceleration. Wow! We have already seen in motion diagram that an object will speed up or slow down depending on the direction of the acceleration. So this is our diagram. As you can see, the boy is throwing his ball in the floor, in the land. So the acceleration is downward, and the acceleration is depend on where is object going, upward or downward. That's why, as you can see, when boy is throwing ball downward, its acceleration is increasing, but when boy is throwing his ball upward, its acceleration is decreasing, and that's why acceleration is depending in his upward and downward direction, and that's why acceleration is also an vector. To see the importance of vector in a simple situation, consider the following example. Now let's see this example. Suppose a fit man jogger leaves their house and jogs north 30 feet to the street lamp on the corner. Again, suppose a jogger leaves their house and jogs north 30 feet to the street lamps on the corner. They turn west, jog another 400 feet, and get to the oak tree 2 minutes after leaving home. We will calculate the jogger's average velocity for the 2 minutes. So as you can see in this diagram, a jogger leave his house to the north side to the street lamp for 300 feet. As you can see, this is house, and jogger leaves his house and jogs for 300 feet to the street lamp, and after that lamp he turn west and jog for another 400 feet. First he leaves the house and jog for 300 feet to the street lamp, and again he turn the west and again jog for 400 feet and get to the oak tree. Again, jogger leaves his house and run for 300 feet to the street lamp, and again he turn west and again run for 400 feet to the oak tree. So this is oak tree. Now it took 2 minutes to reach the oak tree. First he run for 300 feet to the street lamp, and then he run for 400 feet to the oak tree, and it took 2 minutes to reach the oak tree. So we are gonna use average velocity equation to solve that questions which I'm gonna ask you later. So the equation is VAVJ equal to D upon T. Now V and D has arrows. Don't forget this. VAVJ equal to D upon T. So which of the three distance given in the figure is the displacement? Now what is displacement? The symbol D called object's displacement. Again, the symbol D and arrows called the object's displacement. Any symbol with arrows called the object's displacement. So which of the three distance given in the figure is the displacement D arrow? Sorry, only D with the arrow is displacement. Again, only the D with the arrow is displacement. So which of the three distance given in the figure is the displacement? Which of the three distance is given in the figure is the displacement? So in the figure, as you can see, we got 300 feet, 400 feet and 500 feet. So joggers leaves his house and run for 300 feet to the street lamp, and again he run 400 feet to the oak tree, but then he go from the oak tree to his house for 500 feet. So which of three are displacement? So vector is a quantity that has direction as well as magnitude. The symbol D called the object's displacement is defined as the straight line distance from the object's starting position to its final position. Again, displacement defined as the straight line. Again, displacement defined as a straight line distance from the object's starting position to its final position, including the direction from start to finish. Displacement is defined as the straight line distance from the object's starting position to its final position, including the start and finish. Start to finish. So as you can see, displacement is defined as its starting position to its ending position with start to finish. So what is the displacement in here? So obviously the answer is, because jogger leaves his house and reach his house again, so the displacement D arrow is 500 feet, because jogger leaves his house and run for 300 feet to the street lamp. Again he go for oak tree for 400 feet. After 400 feet and after oak tree he again reach at his own home after 500 feet. So starting point is home and ending point is home. Finish point is home. So the answer is 500 feet. Straight line. As you can see, this is the straight line. Displacement is defined as the straight line distance from the object's starting position to its final position, including the direction from start to finish. Okay, so that was it. Now second question is, what is the jogger's average velocity? Okay, so now that we got D arrow, we got the distance, which is nothing but the 500 feet, and the equation is V equal to D upon T, V arrow equal to D arrow upon T. So we just got D arrow, which is nothing but the direction, 500 feet upon T. So the time is 2 minutes. So 500 feet divide 2, which is nothing but the 2 minutes. So the answer is 250 feet. 250 minimum in a direction. 250 minute in a direction between north and west. Okay. So the third question is, what is the total distance, not displacement? Again, what is the total distance, not displacement, traveled by the jogger? What is the total distance traveled by the jogger? So first he leaves his house to the lamp, and then again he leaves the lamp to oak tree. So 300 feet plus 400 feet equal to 700 feet. Jogger's total distance, not displacement, distance is 700 feet a minute. Okay, so the last question is, what is the average speed, not velocity? What is the average speed during the 2 minutes. Okay, so this is simple. We know how to find speed. So average speed formula is VA is equal to D upon T. What is the average speed, not velocity, during the 2 minutes? So the distance is 700 feet. We just learned that what is the total distance traveled by the jogger, which is 700 feet. So we got D equal to 700 and time equal to obviously 2 minutes. So the formula is V A is equal to D upon T. V equal to D upon T. V equal to 700 upon 2. So we got 350 minutes. Sorry, 350 feet. Okay, so that was simple. What is the average speed, not velocity, during the 2 minutes? So the answer is 350. The examples show that velocity and speed are definitely different things. It may seem to you that speed is the more useful of the two, but the following examples show the advantage of the concept of velocity. Okay, now that you learned what is velocity and what is speed, what is the difference between speed and velocity? So let's summarize all of that. Speed is nothing but it shows the how fast something is moving, and velocity specifies both speed and direction. And velocity's formula is same as the speed, which is nothing but the v equal to d upon t. But in the velocity you must add the arrows upon v and d. So the quantities with arrows are vectors, the variables with the arrows are vectors. The vector is quantity that has direction as well as magnitude size. The symbol d called the displacement, the symbol only d, not all of the variables with the arrows called displacement. Only distance, or you can say d with the arrow, is called displacement. And we saw an beautiful example and learn the velocity. So that is it for today's. In the next video we are going to learn a vector applications projectile motion. So that is it for today guys. If you like this video, just like this video. See you guys in the next video. Till then, just learn anything, but just